Your genes load the gun, but your lifestyle pulls the trigger. And if you're an APOE4 carrier like me, the gun is pointed at your brain. Hi, my name is Dr. Kevin Tran, and welcome to another Phoenix Community Expert Q&A, where we dig deep into what actually moves the needle for APOE4 carriers. Our monthly theme is whole genome sequencing, basically going beyond just knowing your APOE status to understanding your complete genetic blueprint and the actionable insights you can derive from it. And today I am sitting with Kian Sadeghi, the founder of Nucleus, a whole genome sequencing company. We explore how carriers like us can use this data to build precision protocols that are truly personalized to our genome. We're covering the big questions. What can whole genome sequencing tell APOE4 carriers that 23andMe can't? How do we translate raw genetic data into actionable interventions? And what are the hidden genetic factors that might be amplifying or protecting our Alzheimer's risks? So just a quick note on all the partnerships at the Phoenix community. We want to maintain 100% independence, which means we never take any financial incentives from our partners, and we ask them to pass any affiliate fees directly back to you as a member discount. So the discount code for Nucleus is in the description of this video. If you're ready to stop guessing and start knowing, apply to join the Phoenix community to join future sessions. With the link below in the description, you can directly apply. And without further ado, please enjoy the discussion with Kian.
Kian, very, very happy to have you with us. We've heard so many great things from Margit about you, so very excited to deep dive into Nucleus and what you do specifically. Maybe you want to start by introducing yourself, because I know you have an interesting background, so that will be pretty cool, and then we can dive directly in.
Absolutely. First off, thank you guys so much for having me. Margaret, thank you for having me being the matchmaker here. We'll be talking about matchmaking today as well. So my name is Kian. I'm the founder and CEO of Nucleus. So I'm a first-generation American. Both my parents are actually Persian. They escaped Iran during the revolution. I sort of have a kind of classic kind of first-generation American story. My dad, he came to this country. He was flipping hamburgers at McDonald's. He eventually became an ophthalmologist. He went to actually Harvard Medical School. They moved to Brooklyn. My mom and dad moved to Brooklyn. That's where I was raised. For me, the story of Nucleus begins, unfortunately, with a personal tragedy. My cousin, she actually went to sleep one day and she died. She actually had a rare condition called long QT, which can cause irregular heartbeat and cause sudden death. You can actually take a beta blocker if you have long QT, but we didn't know, and so she passed away in her sleep. And at the time, I asked my dad, how does this happen? And he said, "Oh, bad genetics." And I was almost 7. I said, "What does that mean? What does that mean?" And there was really no good answer. And so I eventually started studying genetics, and I basically realized that, disease can be viewed more as a problem to be solved. It can actually use genetic science to basically help people live longer and healthier. And that was sort of intuitive to me, right? Because when you see your cousin die at 15 and then other 15-year-olds are alive and well, something doesn't really make sense there. And so I eventually went to Penn, the University of Pennsylvania, where I studied computational biology. And I basically became very inspired by this idea of the cost of reading a human genome. As I'm sure many people in this room know, it used to be about $1 billion to read all of your DNA. So think of your DNA as like a 1,000-page book. It used to be $1 billion, and then in 2020 it was about $1,000 or so. And I thought, it sort of inevitability that this price converges on nothing, and there's going to be a rapid proliferation of this whole genome data. Someone can basically combine 70,000 genetic tests into one test. And, maybe I could build software that stopped what happened to my cousins happen to really anyone. And so with that in mind, I went and I actually started building Nucleus in my bedroom. And eventually I met Lassie Fulkerson, who actually knew Margaret, Lassie Fulkerson, Dr. Lassie Fulkerson. He, long time polygenic scientist. He's been doing this, I think, over 10 years. And he and I became very close. Eventually, we actually acquired his academic project. Margaret actually joined the scientific advisory board not too far after that, probably like a year after that. And at this point, we've raised, over $30 million. We're really the clinical grade whole genome test. We run a high coverage 30x genome on, Illumina's newest X Plus machine. We have a partnership with Illumina, and we really pride ourselves on doing clinical grade analysis like Myriad with the kind of consumer scale and reach of an ancestry of a 23andMe. So that's a little bit about us. Very excited to be here, and happy to, of course, answer any and all questions you guys have.
Cool. Thank you, Kian. It's a very good intro. I wonder if we can just directly dive into like the use cases of for APOE4 carriers, since like the whole community is either homozygote or heterozygote here. What would you say are good few use cases for us? So the majority of people already have done either snippet sequencing or they have done whole genome sequencing with other people. That's how they know their status. But what can they do more in terms of getting insights and getting actionable insights specifically?
Yeah, let's actually dive into this. Let me actually show you the Nucleus platform, and I think I can walk through sort of some of the stuff we do, especially for Alzheimer's, given this group's background. So first thing I want to just actually show you guys is, let me actually take a step back here and just say, this is the Nucleus application. So again, we pride ourselves on like really high quality medical grade genetics, very similar to like you went to a hospital. We're not like sequencing or Dante in that we're kind of like a consumer company. We're CLIA certified, we're CAP accredited, everything's reviewed by clinical geneticists, pathogenic, likely pathogenic markers. The results are very, very tightly integrated together, as you will see. So we pride ourselves on just kind of this beauty and accessibility as well as this quality. I'm going to go specifically to Alzheimer's because that's what I was asked about. And so I'm going to click into Alzheimer's risk. I'm going to scroll down a little bit. It's just to walk through some of the report. So the first thing to know about a condition like Alzheimer's and many common diseases is there's usually hereditary markers. So people always talk about APOE, which is a common genetic marker that does obviously materially impact your genetic risk for Alzheimer's. There are also hereditary markers, APP, PCN1, PCN2, for example. So the first thing we do anytime we do genetic analysis for a common chronic condition like breast cancer, like Alzheimer's, like schizophrenia, like Parkinson's, is we look for hereditary markers that are basically dramatically increase someone's risk for the condition. So in this case, you can see I am, thank God, negative. From there, we run something called a polygenic score. And so you can see here, highlight this. We analyzed actually 33 common genetic variants that are associated with Alzheimer's disease, including those in the APOE gene. You can actually click on it, you can see the 2 copies. So our polygenic model does in fact include the APOE marker. And that's a really important point to say. Sometimes I have patients who have maybe their E3, E4, for example, or even E3, E3. And based off only that genetic marker, they say, oh, look, I'm at above average risk or average risk. And I'd say a couple of things. One is that, Alzheimer's is, more polygenic in nature. So there are other genetic markers that actually shape someone's risk for Alzheimer's. APOE is actually one of several. So it's possible, and we actually have internal data on this, where someone's an E3, E4 carrier, for example, but because of the combination of other genetic markers are actually at average risk. It's almost like, if you imagine like there are little stones that you put in a bag, and there was 10 times, like you can put like 10 stones in a bag, the bag would be really heavy, but maybe sometimes it actually, because of luck of chance, you only get 5 stones in the bag. In other words, your risk kind of isn't as heavy. So that's kind of the intuition for it. Like there's many different kinds of genetic markers that actually collectively shape your risk. And so in this case, for example, you can see that I'm about typical. I think I'm E3, E3. And you can see, you might be wondering, what does it actually mean? We have this nice chart here that outlines basically a normal distribution, and basically you can see the huge range of outcomes, right? So given this includes APOE, you can see a huge spread of Alzheimer's risk. We'd like to put everything in the context of, in this case, obviously my risk today is very negligible for Alzheimer's, but my risk will get much older over time. So we're careful in the kind of way that we present that information. And so I think the key thing I would communicate in terms of risk assessment is there are hereditary markers. There are other genetic markers that actually stratify your risk. So it's possible that you're, for example, an E4, E3 carrier, but you're actually at more typical risk than above average risk, which is interesting, I think, notable. Usually if you have E4, E4, you're almost certainly going to be above average, but you never know about the set of other possible variants that you have. And I think that's something that isn't yet like kind of culturally known. People tend to have a very one-dimensional view of genetics, where they say this genetic marker is really bad, or this common SNP really is really bad. And it turns out for many conditions they're polygenic in nature. Sorry, I know that was a lot of information. Sometimes I talk a little bit too fast, so I want to take a step back and say, does that make sense? Any questions on how you present the results or what we analyze?
Yeah, I think this is like super interesting because we see the difference here compared to other providers, this polygenic score. Not everyone provided. I'm actually curious if it's like something proprietary to my Nucleus. You come up with your own algorithm to calculate it, or what do you base that on?
Great question. So all of our science, we're very clear and transparent what we do. I'm going to come down here so you can see all our methods here. I'm not going to go over it, but basically what we do is we always cite the paper. So in this case, you can see that, you know, if I come down here, you can see all our references, for example. So you can talk about, for example, there's this development of this polygenic score. So the best genetic data always exist in the public domain, right? So the way generally genetic studies work and the intuition for it is, if you ask the question, like, what is the genetic basis of Alzheimer's, of height, of breast cancer? At a very naive level, there's kind of two ways of thinking about it. One way is to look at families that all have breast cancer, which is how like BRCA was discovered, for example. Like BRCA is something like Angelina Jolie had, where they looked at basically families and they said, a lot of these people have breast cancer. That's really weird. Then they identified a really, really bad genetic marker. Right? Another way is to say, if I want to figure out the genetic basis of Alzheimer's, well, let me get a lot of people with Alzheimer's, put them in a group. Let me get a lot of people without Alzheimer's, put them in a group. Let me try to my best to account for all the other variables, things like ancestry, things like sex, etc. And I find that specific genetic markers are basically disproportionately associated in the case group, okay? And then that data you can use to construct polygenic models. And so I would say that the data is public, but all the models that we use to build the data, the ancestry adjustments, the integration of non-genetic pieces of information is actually proprietary. We do like to give all the information that we analyze back to the patient. So for example, you can actually see here the list of SNPs that we use. So you can see, you probably are familiar with this because many people I know here are genetic aficionados. You can see the different SNPs, you can see the different genotype, you can see the risk, non-risk, the major, minor, and also the reported gene. So all that is actually included in your reports. And of course, you can always dive deeper into the references.
And one additional question from me before I open it to everyone else. Do you get the insights on what to do afterwards once you have this polygenic score?
Yeah, you do. So there's multiple ways. So I'm going to walk through each of the different possible things. The first is we actually have this AI health tips in the corner. So I'm going to click on it and see what it recommends for me. We're actually building this out more and more, and eventually it will be something that you can actually talk to. Right now, it's actually calling the day. Let's see. Okay, it talks about omega-3. Okay, it talks about physical activity. It talks about fruits, vegetables, whole grains. You can actually probe this. We actually have a beta. We can probe this more to get more information. I think this is pretty interesting. I think omega-3 fatty acids as a supplement option is pretty interesting. There are also other things you can do with Alzheimer's. And in that case, I'd recommend actually talking to, for example, a genetic counselor. And so we have genetic counselors actually on call that can walk you through a personalized regimen of what to do given your set of results. So if you are, for example, E4 carrier, or if your other genetic markers put you at a higher risk for Alzheimer's, you could do that. Similarly, we actually also have a physician report. And so I'm going to share this tab right now. So our physician report is designed for your doctor. So patients actually take this to their physician, and the physician reviews it and says, oh, okay, look, here's the different genetic scores. Here's the different disease summary. We also do carrier analysis. Carrier analysis is for passing down hereditary risk to your future children. I'm sure many of you saw our family option, or even Nucleus embryo, which is our new embryo analysis product. And so yeah, that's how this works. So I would say there's really three options when you do it. You can use the AI health tips, and you can also probe AI further. You can take it to a genetic counselor, who are fantastic, and also you can take the results to your physician.
Very cool. Any questions from anyone here?
It's Jules here. I have a question around the non-coding regions. I had a quick look at your website, and I think it talked about analyzing the non-coding regions as well. Am I correct in that? Outside the gene?
Yeah. So So when we do, for example, when you do a whole genome test, you're looking at both genic and non-genic regions. So you're looking at non-coding regions as well. What we do is, in the context of like pathogenic markers or likely pathogenic markers, you are basically always looking at within a gene. Many polygenic scores have genetic markers that are actually outside genes. And so that's why you actually need whole genome sequencing often. Like sometimes people are like, oh, why don't you run a whole exome test? Because then you actually can't really build a polygenic model. And sometimes people say, oh, why don't you just do a microarray? Because then you don't get the rare markers that are really bad in a gene, right? So you want to do both, which is why we run a whole genome test, and a high coverage one at that.
And is that just as a follow-up question, is that the main differentiator between your company and other companies? Is it the whole genome approach?
There's a lot of differentiator. One is definitely whole genome. So obviously, if you look at company like 23andMe, they're SNP chip, right? So fundamentally limited. I think probably everyone understands that here. Another is that we're actually clinical grade, so we're CLIA certified, we're CAP accredited. So everything we do is actually supposed to be used for medical purposes. So we actually have a clinical geneticist that reviews genetic markers. Other companies, they actually, we have used all the companies, and we've had patients use other companies, and they just report a genetic marker out that doesn't even exist in their DNA. I mean, it's crazy. And so, we pride ourselves in our kind of clinical grade quality. And the next is actually really interesting too, is we take great care in integrating in a huge range of non-genetic pieces of information as well. So I think it's something that actually gets underappreciated by the product. If I scroll down, this is heart disease. Everyone here knows that heart disease is based off of not just genetics, but also non-genetic pieces of information as well. And so if I come down here, you can see that this report is based off cholesterol, my cholesterol, blood pressure, diabetes, smoking, sex, and my whole genome. So all those pieces of information is used to calculate my risk, which is another very innovative part of the platform, which is for many of these conditions, it's not just genetics, which you guys know. And so we managed to actually not just do the rare stuff, not just do the common stuff, but also integrate non-genetic pieces of information all together to calculate risk. And so now it's clinical grade, you have these kind of integrated genetic models. And also I think a very important point, especially when you build a consumer application, is it's intuitive. People understand it. People want to click around. People want to engage with it and experience it. And it's a very different than giving someone like a 50-page PDF report, which trust me, I've seen them. And I'm like, oh my God, I don't even understand what this report is telling me. And I'm supposed to be, I'm the founder of this company. I don't even know what they're trying to tell me. So that's one thing that we really pride ourselves on as we built this application.
Thank you.
Absolutely.
This is very cool that you can add like the non-genetic risk. So what type of information can you add, like blood work and anything else?
Yeah. So when you sign up, you can actually, it's cholesterol, there's like A1C, there's blood pressure, we use age, obviously, sex, BMI. There's a bunch of others. We use diabetes status. There's several others. I think we use around 10 different non-genetic pieces of information, which to my knowledge is by far most. Usually the best someone will do is they'll stratify based off sex. So like male breast cancer, female breast cancer, which is, fine. But like for a heart disease model, there's actually multiple things. I don't want to geek out too much on this call, but there's actually a lot of things. So the first thing is we look for really bad markers, right? We don't just like tell you, here's a single SNP. Like a lot of companies, what they'll do is I'm going to come down to scientific details. They'll look at one SNP and then they'll be like, oh, your genotype is GG. And then the risk and non-risk allele is GC. Oh, so you're actually at risk of heart disease. But this one SNP is explained so little. It doesn't mean anything actually. And so I cannot tell you how crazy it drives me when people bring me their single SNPs, because that SNP is like 1/100th or 1/1,000,000th in some cases of actually the risk assessment, because each of these have very little effect. And so you need to build models that actually combine up to 1 million of these. So that's one of the first two things we do. But then we also do the rare stuff. So sometimes someone might give someone like a polygenic score, like they'll give them this kind of chart. But if you have let's say, average polygenic score, but then it turns out you have a genetic marker in your, let's say, LDLR gene, that doesn't mean much, because now suddenly you actually had much higher risk. So you can think of it as like the genetic marker in this gene trumps the polygenic score. And so we've actually built out that logic into every single disease report in that platform. And then we go one step further by integrating in the non-genetic piece of information. So we don't just do the best genetic analysis you can do on a high coverage whole genome. You then integrate in non-genetic piece of information, like what I said, sex, age, cholesterol levels, A1C, etc. So as you can see, I take great pride in this. My baby. Yeah, sure, Elizabeth.
Please. Hi, Kian. I think I have two questions here. So one of them is, okay, so I've had breast cancer and I'm looking at the APOE4. So if I'm getting a report from you, like, can we look at multiple areas at the same time, or is that like two different reports?
Do you mean like if I want to look at breast cancer, like this is male breast cancer, so it's going to be slightly different than female breast cancer report. But like if I want to look at this, and then I also wanted to like look at Alzheimer's like on the screen at the same time?
Well, just practically speaking in life, I have people advising me related to avoiding Alzheimer's, and I have people advising me related to avoiding a recurrence of breast cancer. And sometimes they conflict, and sometimes they're not working with genetic markers that put me at higher risk of one or lower risk of one. And so I'm wondering, can I get that information with what you've got there?
So we would provide you a risk assessment on breast cancer, and then we'd provide you a risk assessment on Alzheimer's, for example, beyond APOE, just that marker. And then honestly, it would be a physician or a genetic counselor that would consider those respective scores, right? And they're probably disjoint. They're probably like not, they don't use the same steps. There's sometimes polygenic scores actually can, but they're probably disjoint. And so then the physician or genetic counselor would basically evaluate your specific scores and then design some sort of appropriate medical or even lifestyle next steps depending on those scores and if you have any hereditary markers as well.
Okay, and then so I've had my 23andMe done a long time ago, and so I know that I have the APOE4 gene, the 3/4 gene, but there's other things too. Like I have MTHFR. I have some things that are related to my inability to process or create glutathione. I don't know which SNP anymore, but there are complicating factors in there. Would those show up if we're doing an APOE4?
So the answer is a couple of things to know. This test is very medical focused, very disease focused. There's some traits, like we do traits here if you're curious, IQ, etc. But it's very medical focused. As a general rule, as a company, we don't analyze single SNPs because they tend to be very weak effect. However, what customers love to do is we give them access to the raw DNA data. So you can always download your raw file. And in doing that, you can actually look at your single SNPs if you want to for some sort of, diet, if you're really interested in that. As a rule though, we're very focused on building medical grade polygenic models, and also carrier status. We don't give as much like, oh, you should take this, pill or do this diet, because that science tends to be admittedly softer. And so we tend to stray from it.
It's not as much that, I don't think, but, if you are an APOE4 carrier, you are worried about how well you detoxify toxins. I mean, for one thing, and you have cardiovascular concerns. How do we process lipids? And I mean, those are relevant questions for all of us. And there's other ones based on what we've discovered through our genome. So is that going to highlight that information, or do we have to go create it?
So I would say the important thing to remember is that you should, if you're an E3, E4 carrier, for example, like that is one marker, but it's not the marker. Like it's very well possible that you're actually at an average Alzheimer's risk for your other set of genetic markers. So the first thing I would do is get that kind of complete assessment, and then based off that complete assessment, determine what appropriate lifestyle measures could make sense. This product is very focused on kind of a clinical grade like risk assessment. In terms of the specific next steps, it really varies patient to patient depending on what their unique polygenic score is. We're trying to eventually build it out with AI, but it's very hard to give actually truly personalized next steps, because even if someone's like an E3, E4 carrier, for example, the risk of Alzheimer's actually varies quite a bit amongst different patients. And so we try to make sure we build the best models to do it. And so that's kind of how we think about that as a company.
I think this is Margaret. I think what she's asking about is sort of more nutrigenomics. It's the digestion of various supplements. How do you metabolize lipids? How do you metabolize folate and all these kind of. And I think to some extent, as the scientific advisory board, we are looking at some of the drug metabolism rather than the nutrigenomics. But there are companies who are actually specializing on that. But as Kian said, they often exaggerate the effect. So this whole MTHFR, which half of the people have a so-called deficient MTHFR in the medical community, is pretty much saying, oh, people are selling their methylated folate to half of the population saying they can't digest it. And it's not as well established. And but I mean, that we can talk that another time, but I don't think Nucleus has done a lot of this nutrigenomics in general so far.
Yeah, we haven't. And I would second that point, which is, MHCFR, everyone asks us about it, and that marker is very low effect. I want to emphasize this. I know it's a very common kind of pop culture, pop science marker. Everyone's heard of it, and it's great that people engage in genetics in that fashion. It is very low effect. So there are people, for example, with or without the marker that actually processes homocysteine very different. Like it's very little effect. Like it's sort of like it's using like a very, 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 very crude model, which is why generally as a rule, as a company, we don't report out on it. However, I do want to emphasize this. We do give raw data, and patients all the time download that raw data, and they can go and they can get basically all the kind of analysis on like genetic Genie, for example. We like to use, you can upload your DNA data there. I can't say I endorse genetic Genie. In fact, I definitely think some of the stuff they say is wrong, but I think if patients want to engage further with their information, that's definitely an option.
But your strength,
right?
The bottom line is that your strength is you're looking at everything and you're giving people their risk assessment. Like, okay, you've got the gene, and how bad is it?
Exactly, and that's really important to me, because before you can take any next step, you need to understand what's your actual risk. Right, that's really important. And so our perspective as a company is like, hey, let's, especially for, again, APOE is such a good example of this, because it's one marker. If the main takeaway I would say from this meeting for all the patients here is that you can be E3, E4, but actually average risk for Alzheimer's. And that is so important to say, because that is completely lost from the narrative, and many, physicians and even some geneticists aren't privy to that fact with the nature polygenic score. So the first step is to get an accurate risk assessment. And I would say that, that's the key, and then you can determine what to do next.
Thanks.
Absolutely.
To continue on what Elizabeth was saying, right, to link the risk to the actual actions. So the two ways you mentioned earlier, it was AI or using a geneticist. Which one for you right now, and I guess in 1 or 2 years' time, is the most powerful, accurate, or relevant?
My favorite question. I think they're both going to be necessary, honestly. I mean, what we find with AI is that there's a problem with AI where it can be unreliable. Like, the thing with medicine is you really don't want to be wrong. Like, you really don't want to be wrong. And the thing with AI is it doesn't mind being wrong. It just says whatever, you put into it, it gives you something out, and it's very finicky. And so the concern with AI is that, like, it's very finicky, and there is sort of like a rigor problem. Like, the one thing about giving out results like by a GC, right, is that it's deterministic. So like if I send 2 patients with the same risk, the GC is going to give the same advice, right? Meanwhile, with AI, if I send 2 patients with the same risk, let me tell you, it doesn't just give the same recommendations. Sometimes it can vary widely for really no good reasons. Like stochasticity just doesn't make sense. And so I think you're going to need both. I think the AI is going to get better, to be clear. I think though GCs as a general rule are underappreciated in genetics. They're so critical. They're so smart. They know so much about not just the genetic, but what to do. They're really that link between the genetics and then what to do. And they also get a good family history assessment too, which I think can provide further weights of like, what is my actual risk, which I think is really important. So that's kind of how I personally think about it.
Because I mean, at least my experience is it's very difficult when you're looking at multiple comorbidities. Like Elizabeth, you mentioned like breast cancer on one hand, and then you have APOE4. Then you need to find someone who knows both like very deeply, and then potentially you have a third comorbidity coming in, and then I'm pretty sure like a human doesn't have that much knowledge that is up to date versus AI.
No, that's definitely true. I definitely think I'm a big fan of what I call P4 medicine. So it's participatory, it's preventative, it's personalized. I think that like basically medicine is becoming data science, and the more variables, the better. And the more variables you can get, the more accurate risk assessments you get, the better recommendations you get. That said, giving the recommendation to patients to all take their data to AI, I think do it, try out with it, but take it with a grain of salt, right? Obviously, I don't want a patient to, I sound like a doctor now. I sound like my dad. Oh my God. I don't want a patient to accidentally, inadvertently hurt themselves, right? Excuse me. But seriously. I don't want a patient to inadvertently like do something based off of AI that they can't necessarily double check. So I think the real power comes in both.
Cool. Any other questions from the audience? Otherwise, I have a few still. On the more creative ways or the things that you've seen people use whole genome sequencing, what are things like cool use case that you've seen in terms of creativity, weird things that people have used whole genome for?
Look, I think a cool thing is family planning. So we have a cool thing where you can see actually here I'm a cystic fibrosis carrier, which is pretty, I actually didn't know that until I did Nucleus. And so you can see I'm not a carrier for over 900 conditions, but I am a carrier for cystic fibrosis. You see CFTR here. So if I click into that, you can see that, my kids could be at higher risk. And the next step is to actually add my partner, right? So if my partner is a carrier, there's about a 25% chance our kid will have the condition. If my partner is not a carrier, my kids are fine. And so if I actually go add partner and I click yes, I agree, I can actually copy the link and share with my partner, and then we'll run all the possible combinations with them to see if you're a genetic match. So we basically productized family planning. I think it's really cool. And I think customers love this. They really love it because it's like making genetics like engaging. And so once you do that, if you, for example, are both a carrier for the same thing, then you could do, if you want, it's obviously up to the liberty of the patient, we could do IVF. If you do IVF, you could actually then screen out the baby with a really severe condition. And then you can actually do nucleus embryo, which helps you basically pick the baby at the lowest disease risk. And so now you can see how all these technologies come together, from family all the way to procreation and reproductive technology. And so something about genetics, which is really interesting, is people think, family planning is one kind of genetic test, and then breast cancer screening is another kind of genetic test, and then 23andMe is another kind of genetic test, and then PGX, which is pharmacogenomics, which we can talk about, is another kind of genetic test. But it turns out actually all of these applications can now be under one test through the power of a whole genome test like Nucleus.
Very cool. I wonder how early in the dating process you start sharing that to see.
Well, I like to joke, you sit down, for me, I sit down with a girl. I say, where are you from? I say, where'd you go to school? What do you do? And then I say, have you done Nucleus, by the way? Are we a match?
Comes very fast.
Yeah.
And in the end, IVF, you could, I guess it depends on the country and the regulations, right? But you could screen out the majority of these students. Like you could select the embryo.
You could, yeah. You could select it for hereditary disease risk. So for like this stuff, you could screen out for like cystic fibrosis, for Tay-Sachs, for PKU, for BRCA, for LDLR, these sort of things. For polygenic risk, you can't ever fully get rid of polygenic risk. Like everyone's going to be at risk of something, but you can help reduce it by a pretty reasonable degree. Again, depends on how many embryos you have, and depends on the couple's risk. There's a lot of factors there, and I don't know how much we want to go into the reproductive side of things, but that's how it works.
Very cool. Yeah, that's something I haven't considered at all. Yeah.
Well, Kevin, I don't know if you have a significant other. You should see if you're a match. I mean, you don't know.
Yeah, for sure. Another question, or unless like someone else has something. Yeah, okay. So we have a lot of members who they've known their status for like a long time, right? APOE4 status, they have optimized everything like for decades. They all the lifestyle interventions, they exercise, the diet, supplements, everything is already like super maximized. Do you feel that they would still need a whole genome sequencing to go like deep dive into fine tuning that, or would that be overkill?
Yeah, absolutely. I think the thing is that APOE is just one marker. And one marker does not necessarily tell you your risk. I think APOE will increase your risk by about double, approximately. It depends on what age group you use. But let's say it increases your risk from 15 to about 25%. You guys probably know the numbers perfect better than I do. I don't memorize every single disease risk numbers, but I think it's probably approximately like that, right? Like your risk could be still much higher than that or much lower than that, depending on your other set of genetic markers. And so it's really important that you do a broader test. You get your polygenic score. And then once you get your polygenic score, you can actually determine, okay, where am I? Because maybe your risk is actually at 15%, but maybe it's actually at 45%, almost flip of a coin. And so that's, I think for me, I think that's really important to know. So yeah, I really recommend it. And obviously, when you do a whole genome test, you're not just looking at a single SNP, you're looking at millions. And so by that logic, you can actually look at all the diseases, other diseases too. And you might be surprised by what you find. Like, for example, not to scare anyone, but my highest genetic risk is for schizophrenia. Crazy, right? But this is really interesting for me because I actually didn't know that. So you can see that I'm in the 99th percentile of my genetic risk for schizophrenia, but my overall change is still really low, only about like 1.4%. And so for me, I was like, okay, well, sometimes someone might say, oh, well, schizophrenia, like, what do you do? For me, I've personally never done any drugs. But now, given my genetic risk, I know really to never do any psychedelics, right? Because there's a reason why when you give two people the same drug, right, especially psychedelic, one person can get, lose their mind, another person can't. It's because of genetics. And so this was really interesting to me. And I actually found out that a lot of founders are high genetic risk for schizophrenia. That's something, right? Come on, guys. That's a funny joke. Come on, at least you saw smiles. Come on.
Yeah, where you are taking it is exactly what I was saying. In my other life, I work with a lot of people who have rare genetic diseases. And one of the things that a lot of them report, especially parents of kids with that, is that the doctor is hyper-focused on this rare genetic disease that the kid has. And they are at equal risk as anyone else for diabetes and all the common, and people forget that. And so I think if people have optimized for 10 years based on their APOE4 profile, then they may forget that they have the same risk as anyone else of colon cancer or breast cancer or whatever. And so I think looking at whether there is an increased risk or decreased risk of something else, just like you were bringing up, schizophrenia wasn't what your focus was on, heart things and long QT, that's what got you there, but that came as a surprise. And I think some of these you can do something about. I mean, I did not know that I was at high genetic risk. Well, and Nucleus says I'm one of the cases where I have APOE4, but Nucleus says I'm at average risk, whereas 23andMe says I'm at 2 to 3 times increased risk because I'm apparently have some of these other variants. So
that's great, Margaret.
Yeah,
you're lucky.
I think the not forgetting that there are many other diseases, and just because you are at high increased risk for Alzheimer's doesn't mean, I think Elizabeth was saying this earlier, you can have two things. You can have breast cancer in the family and you may have a complete surprise. So that's part of why I also think it would be useful. I don't know whether figuring out if you were APOE4 E3 that you actually are only average risk, whether that means you should stop doing the things you're doing currently that prevent Alzheimer's. I think they are they are generically good enough that I wouldn't stop them. So
Agreed. Still good to know though, but agreed.
So Kian, when you're doing your risk analysis for Alzheimer's, are you identifying, for example, and by the way, you're high for schizophrenia and you're also high for diabetes. Like, would that come out in your risk assessment?
Absolutely. So the first thing you see when you get your results is this health summary page. So we break it down by what you're elevated, average, decrease, and extremely low. And so you can see right away, schizophrenia is actually my highest genetic risk, then arthritis, migraines, gastric cancer, MS, and depression. So I can actually click into like arthritis, for example, and I can see my, different risk, different scores, and then here, migraines, another great example, right? You can see that I'm at, about double the chances, migraines. And so, yeah, absolutely. It's basically, we really pride ourselves on the display so you can see everything. And then if I really want to go look at Alzheimer's, I can click this button and this button will sort by risk. So, oopsie daisy. Okay, so you can see these are my elevated risks. If I go to Alzheimer's, you can see I'm at average risk. So yeah, that's how it works.
So you can take some of this information and then go somewhere else and say, I have difficulty detoxing, so I want to learn more about that.
Yeah, you could. Yeah, and then you could take the raw data. Yeah, exactly. You could. Yeah.
If we focus now on the value itself of my nucleus, right? I separate it in two sides. You have the more, let's say, hardware side of actually sequencing it, your gene, which is like Illumina, I think you mentioned, and then you have all the software side, which is here. Would you say you differentiate more on one or the other, and where you differentiate compared to like the others?
Software. I think sequencing a genome is becoming more and more commodity. It's not there yet. It's still quite complex, but eventually it will be. And the application layer is king. So the interpretation of the DNA, the presentation of the results, the interpretation of the results, the way you divide up the results, all these things are critical.
Is it possible to upload and only have the application layer if we already have sequenced by someone else?
If you have a whole genome file, yes. So if you have a VCF file, for example, you can upload your DNA, and yeah, it's you go on a website, and if you scroll the way down the website, there's a thing that says upload on mynucleus.com, and then you can just upload your file. It's very simple.
I have a question about that. Originally, I did 23andMe, and then I think I ran it through Prometheus, and then I made copies of anything that I thought that made sense to me. So obviously not everything with that much data. And so I have files somewhere on my computer. I don't actually know if it's the whole genome or if it's parts that maybe I selected because it was about 10 years ago. Would you be able to tell from the file, like, oh, this is not complete?
If you did it 10 years ago, I don't think you did whole genome. You did something like 23andMe or something like Ancestry. I don't think 10 years ago it was possible to get your whole genome sequenced for any reasonable amount of reasonable price. And my understanding is last time I looked, Prometheus didn't allow uploads of whole genome. It only allowed upload of SNP data. Have you checked that recently?
No, no, I haven't. And I think you're probably right. 10 years ago was time.
Yeah, I was going to say that. Almost certainly it's a microarray file, which is a smaller snapshot of someone's DNA. And Prometheus, it's at the time probably wasn't accepting whole genome files.
Okay.
When we look at pricing, so can you go into exactly like what it includes once you start? Because I see different pricing. So I see $4.99 and then $39 per year. What does that entail?
Yeah, absolutely. So let me just pull up the website so you guys can see it yourself. Cool. So obviously includes whole genome sequencing, which also includes cancer screening, heart screening, neurology screening. We screen for over 900 conditions. It's 100% of your DNA, really 99.9%. It's clinical grade. It's 30x sequencing. We obviously have, oh, look at that, Margaret. Very nice. Very nice. We have Robert Pullman, Jerry Lasse, Barry, these people on our team. We have access to genetic counseling. We have the ability to download the DNA. I think we have, let me see, I think, oh, here it is, maybe. Health, Bloodwork DNA Health Does, yeah. So it helps you understand your body, have healthy children, live healthier longer. It includes family planning. I mentioned that. I showed you guys the platform. Okay, yeah, that's what I was looking for. So it includes this test kit. Then obviously the Nucleus family, Nucleus Health, and Nucleus AI. Membership's really cheap. It's like $40 a year. We're constantly updating the analyses to get it better and better and better. As mentioned, we're HIPAA, CAP, and CLIA. Yeah, so basically when you buy $500, it's the DNA testing kit plus the membership. It's really just the most comprehensive analysis in genetics that exists today.
And that $39 per year, where do you see this going? Are you focusing on specific aspects, like the family planning, or like?
Yeah, great question. So a lot of things. So one is that, for example, pharmacogenomics, which is how your DNA affects metabolism of drugs. That's actually not yet on the platform. That's you want to add that to the platform. It's a huge area. People love that because it's very actionable. Another is procreation simulation. So procreation simulation is people actually simulating their babies. We're very interested in that. So that's going to be added to the platform. Yeah, so it's a lot of fun, different features will be added in. Those are just some examples. What's going to be added in probably a homocysteine polygenic score because people keep asking about it. So one that looks beyond MHFTFR or whatever the acronym is. So yeah, that's how we can plan it.
Yeah, very cool. I feel like in terms of like coming from a consumer, once we have done it once, like the whole genome sequence, it's more about going around the different like providers who have these different layers of software and then uploading it and then coming back every year to see if something is new, right? Or do you feel like there's a better use from?
Well, I would say we update around probably once a month. Depends actually, but around. Like for example, we're about to add in 1,000 genes. Just for just 1,000 genes more added. So I mean, we do a lot of stuff. I mean, the genome is big, there's a lot of data, and so I think it's important to keep updating it. And polygenic scores improve too, right? I mean, those genetic scores you get are constantly improving. Like there's new data, and then there's new methods, and people get more accurate assessments as well.
So you can go in at any time, and you can see what's happened in the past 3 or 4 months, and has my risk changed at all?
Yeah, exactly. That's the cool thing. Yeah, exactly.
Ian, I did 23andMe forever ago, back when you could find out you were a 4/4. After that, they locked it. You had to unlock it. But,
I remember that, yeah.
Recently, I did self-decode. So I did a new test. And self-decode is interesting, but it kind of, for each thing, it tells you eat this or don't do that. And it doesn't match. So I don't have the brains to sit there and put it all together. Is self-decode test, though, similar to your test, or is yours a whole different test?
Self-decode is like, it's very, honestly, kind of gimmicky. It's very consumer, like, it's not really clinical grade. It's not even clear to me what kind of test they run. Do they run a microarray test?
I've never heard of that one. But I know there's genetic palette, and there are all these. I can look what is it called?
Self-decode. It's Kashif Khan. He talks on a lot of podcasts, and for about $3,000 you can get him to look it over because I think his brain can look at it and actually give you some actionable but I didn't spend that. And just for the regular test, it's interesting, but if it's only going to tell you what to do for each thing and doesn't mix them together, which is kind of what I was hoping the computer would do.
Yeah, it says
I'm looking at
150 comprehensive DNA health reports and then personalized diet, supplement, and lifestyle recommendations. So it's
this is very it's not very medical. Yeah, we don't really do this. This is more like this is like for like, you know, like what's it called? Like if you want to get like a supplement based off your DNA.
This is the nutrigenomics.
Very soft.
Yeah, exactly. There are a lot of them that do this, and it doesn't say on their website exactly whether they do a specific panel of variants or whether they do SNP chips. It's unclear. Yeah, maybe Nucleus should put the genomics stuff, the nutrition supplement, metabolism of folate, and all that. In panel that
yeah, I mean, Margaret, you know, if I went to Lhasa and I said that, he would say, Kian, that's not science. That's not science, Kian. So yeah, I know. They want it, you know.
Yeah, I do want us to ask something because there were several people here, and I think Kevin was asking about this. Do you currently allow people from outside the US to order?
Yeah. So it's not public on the website, but we do it. We're going to push it public on the website probably in the next couple of weeks. We have a couple large announcements coming out. So if you, for example, want to do it right now, honestly, email me. Here's my email. But it makes it super easy for people. My email is ks@mynucleus.com. ks@mynucleus. I think that's correct. So if you email me and say, hey, Kian, you know, I want 2 DNA kits shipped to, I don't know, Spain or something, I'll have my team do it for you.
Oh.
Yeah, I think in terms of feedback, right, what we see from the questions and everything, it's quite difficult to really differentiate between the different providers and decide where to go and what is actually what we call like cold science and not. And the second part is it's less actionable when everything is siloed into these diseases. Like the same way where you do like polygenic score for one specific disease, I feel like it would be very interesting to have just an overall big view and then have the actions like based on all the different risks, on all the different diseases, rather than just siloing them one by one. That would be like way more practical, I think.
Yeah, I mean, it's good feedback. The difficulty of it from an implementation perspective is, you know, like if you have high risk for schizophrenia versus high risk for heart disease, it's very different protocols. Also, it's a question of how medical do you want to make the platform, right? Some genetic tests like Nucleus is going to be used in the clinic. Doctors do not want to advise their patients to take some supplement. It's just not what they do. That's another difficulty, right? So if you give them some sort of generalized protocol, that's really what they're looking for. And so it is a really difficult problem, Kevin. So it's well noted. What I was thinking of maybe doing is you could maybe do some sort of like make it easier to summarize all the results. We've tried really hard, but you could maybe like start with the action items. Just like, hey, here are the things we think we should do. But also, again, if someone has a disease, like if someone has a BRCA variant, they might need a double mastectomy. It's very serious, right? It's not like, you know, they need to talk to the doctor. So it's a balance. It's a really tough balance.
Yeah, but very, very interesting space. Just a quick word on nutrigenomics, because I'm about to go into that as well. So you guys think it's not very solid for now?
Is this being recorded? I would say I don't think we know. It's not very solid. Nutrigenomics is very unfortunately. I think nutrigenomics is one of those things that everybody wants it to work because it's so simple. It's like, oh, you have this SNP and you have this diet, and then you're going to be this healthy. It's like so linear and so simple and so clean. But unfortunately, biology does not work that way. It doesn't. And to be clear, I'm not saying don't do it. Like, definitely look into it. It's fun, but treat it more like kind of like a horoscope, I would say. like, oh, this is fun and cool, but like, I'm not going to die today, even though the horoscope says like I'm going to get hit by a bus. You know what I'm saying? It's like, take it with a grain of salt, basically.
I mean, I'm a geneticist and I've done a lot of these tests. So I've uploaded my 23andMe or ancestry profile to several of these nutrigenomic sites. Unfortunately, not the one that the question was about, the self, whatever, but I've uploaded it. The one that was pretty extensive was something like genetic toxicology or so. I can't find it even more, so it's probably gone. And I've looked at many of them. And so one of them basically kept telling me to avoid soy. And I was trying to figure out why. And this is another myth, like this methylfolate and MTHFR story, that they say that soy is estrogen-like, and for something that I had, the soy would react like estrogen. And so that's, I mean, it's not scientifically established that soy estrogen does anything to humans. So, but that's a big sort of folk myth, just like this whole methylfolate business. So it was interesting what they were seeing. So I have two variants in MTHFR, but two different variants. And in the end, this means that I'm about average, because what they call deficient variants is actually the normal phenotype in most Caucasians, at least. So, and I think people don't understand this, and so there are sites at NIH where they say, okay, it would reduce your ability to digest folate by 1.5%, but there is a lot of redundancy in that reduction. So in the end, you will not be folate deficient based on if you just take normal folate. So for most people, I think it's selling supplements, and it's not very useful.
Is there a way to, like a rule of thumb, to know what is more robust versus what is less robust in terms of insights that you get out of whole genome sequencing?
I would check to make sure the company's CLIA and CAP. And I make sure, sometimes they say CLIA CAP, but they mean the wet lab. Like the dry lab should be CLIA CAP, which is really important. It's like an important distinction. CLIA CAP just refers to like the clinical quality of the testing, that they've run validations to show that it works. I would also probably, and this is, probably useful for anything, but I'd ask ChatGPT and say, hey, imagine you're a really rigorous scientist, what do you think of this analysis? And honestly, if you ask it and frame it that way, it's pretty good. It'll be like, many experts say that MTHFR is no good because it's really weakly associated, but it could be useful for pop culture, and that's like the right answer, So like that's one thing to do.
Okay, good advice. All right, I think we're cruising near the end.